Time monitors record fields as a function of time. Here's an example of a plot of the electric field over time from a monitor placed between a source and an object. You can see two pulses in the time signal. One pulse is the initial source pulse, and the second pulse of smaller amplitude represents the reflected light. When you add a time monitor, by default the monitor type is a point monitor. You can also have 2D or 3D time monitors, but they require more memory, and the memory required will increase with simulation time. However, you can reduce memory requirements by changing the time window where data is recorded, or setting the number of snapshots to take over the specified time window. By default, the time monitor measures the electric and magnetic fields over time. However, you can also choose to record the pointing vector too. The time monitor also returns the Fourier transform of the measured E and H fields as a result called spectrum if the time monitor geometry is point. From the plot of the E fields over time, you can check whether the simulation time was long enough. Typically, we want the simulation time to be long enough so that the injected source pulse has time to propagate through and decay or exit the simulation region completely. For example, here we have a source injecting a mode into a waveguide, and a time monitor is placed near the end of the waveguide. If we plot the E field amplitude over time at the time monitor location, we can see that in this case that the pulse is not finished passing through the monitor location before the end of the simulation time, so the simulation time should be increased. From the plot of the spectrum of the E or H fields, you can find the resonant frequencies of cavities by the location of the peaks in the spectrum. In band structure simulations, we inject light to excite modes of a photonic crystal lattice structure and locate resonant frequencies to determine the frequencies of the bands of the crystal. Another use of the time monitor is to record and return data from plug-in materials. Material plugins were introduced in the Material Properties section of this course. Material plugins can be used to implement custom material models, and these models support additional custom data in the form of storage fields, which can be calculated at each time step while running the simulation. Time monitors can be placed in these structures where material plugins are used, and can be set up to return the storage field data over time by specifying the material plugin name. For example, the 4-level 2-electron material model has storage fields that return the population in each energy level over time. And this allows us to see when the population inversion occurs, which allows for lasing. The full details of the 4-level 2-electron pump probe simulation, which was used to generate these figures, is linked below. Applications where the time monitor are extensively used include cavities and resonators, band structure, and nonlinear simulations.